Alrighty, so we're gonna get started and jump right into it. I'm doing my project. It's the hands-on project. I decided that I'm going to do a Pi-hole server. What Pi-hole is it is a network-wide ad blocking DNS sinkhole. So I'm going to be building a virtual machine and securing it, and it's going to do ad blocking network-wide. So I'm going to be using Virtual Machine Manager, or QEMU, KVM virtual machines for my ad blocker. So we're going to make one. And I already chose an ISO. I'm going to be using Ubuntu for this. So let's find Ubuntu. Browse. So Ubuntu live server. Doesn't need to be super strong because it's just doing DNS querying and stuff like that. Doesn't need to be too big either. Let's name it the Pi sinkhole. Because Pi-hole itself is actually meant to be run on like a Raspberry Pi, hence the Pi name in it. But I found that it actually works really well too if you just want it like low resources running on your actual system in a virtual machine. But here we go, we got it running. Jesus, I can't see any of that. It's small. Try or install Ubuntu server. Jeez, it's all tiny. And while that boots up, I actually want to check out the details of my virtual machine, because I need my NIC to be on. And in order for this to really work on my network, I can't be using NAT. I have to bridge it with my actual Ethernet connection. So I'm going to do a bridge device, and I'll set that up after I finish setting up the Pi server here, getting it installed. Let's see, virtual IO disk 1, Pi-hole sinkhole. Okay, it's all there. Jeez, I cannot. That's tiny. Oh my god. There we go. Okay. English. Jeez, it is tiny. Okay. Language, ENUS, keyboards, yeah, done with that. We want to Ubuntu server. Choose base for the installation. Ubuntu server. This is something else too. Damn, is there any way I can make this bigger? It is tiny. Tiny. Ubuntu server minimized or Ubuntu server, I think full is what it's trying to tell me here. The version has been customized to have a small runtime footprint and environments that are not supported to log in. I'm just going to stay with the basic Ubuntu server, and we're going to go ahead and go forward with that. I'm going to leave our network settings the same. The network needs to be rated here. Close. Ethernet notes on DHCP create bond. Alright, well, since I don't have a network just yet, we're going to continue without network first. Proxy address, we don't need any of that. Just continue, go forward with that. Mirror address, that can just stay the same. And customizing the snap start version of the installer. Okay. Continue without updating. We're going to continue without updating for right now since we don't have network service. Yeah, that looks about right. It's all going to that. Dev local disk, 25 gigs. Custom storage input, and we're going to do next. available devices. We have our LVM volume group, and that can stay the same. Have all of our devices here too. And I'm going to go ahead and continue. We're done with that. And it's going to selecting don't show below will begin the installation progress, and we're going to go ahead and begin the installation. For the name on the server, I'm just going to name it Pi-hole. My server's, my name, just going to put Ben on there. My server name is Pi-hole, a username Pi-hole, password. Got that going there and done. We can skip the Ubuntu Pro setup for now and continue. We want to install OpenSSH server, import SSH setups. We don't have anything for that just yet, but we do want to install the SSH server. And this is going to go and show me all this. Next, close. And it looks like it has finished, so we're going to reboot now. Alright. Since it is a virtual machine, I don't think it's going to be able to unmount all this, so I might have to manually just restart it. So we're just going to force it off. And we're going to start it back up. Details, we're going to pull out the CD-ROM, remove the CD-ROM. Okay, force off. Remove the CD-ROM, it's gone. Turn it back on, console. And we're going to go to Ubuntu, and we can boot our server. Okay. Scale display. Always. There we go. Boom. Now I can see. That makes it way easier actually now. Yeah. Loading app armor profiles managed internally by Snapd. So we do have app armor already installed, so that's already doing something. Network name resolution, network names. It's gonna take a minute. Start job is running. Wait for network to be configured. I don't think it's gonna be configured because it's waiting. But in the meantime, we're going to go ahead and create our network bridge. So if I show you my network addresses right here, I don't have a bridge yet. I don't have one set up. But I do have my IP here as static, so it's not gonna change, it'll stay. And I don't have to worry about it changing later. I'm going to go ahead and open NM2E. It's a tool for customizing your network settings on the terminal. I'm going to edit connection, and I found it's for some reason it's the only way I can actually make a network bridge. I can't use the other tools like in my network manager to do it. I have to do it from here. I'm going to create a bridge. It can just be called NM bridge. It's going to be the name that we're going to use later for it. And for the slave device, we're going to add an Ethernet connection. And the Ethernet connection is going to be 1. It's all going to be automatically connect, available to all users, automatic. This is show all automatic. Okay. I got an Ethernet connection, and we can do okay. Alrighty. So we have our bridge connection and our normal Ethernet connection that we have. For this, I do have to delete my own Ethernet connection to use that on the bridge. So the bridge now has everything. And if we do that, we get edit connection, make sure it's still there. Yeah, bridge connection's there, and we're going to quit. Just okay. Alrighty. So do ifconfig again. We can see that now we have our bridge, our network bridge right here. And with our Ethernet device up here, it's all still here. I don't think it's found an IP address just yet. I don't think it's been assigned one just yet, but it is loading, I believe. Let's check it again. ifconfig, the global interface, the bridge. See, now our bridge has an IP address. So that means that we can now use the bridge on our virtual machine, and it's on our actual Wi-Fi now. It's like actually able to communicate with other devices on the network because now it's part of the same subnet. So we can go ahead and in here, we're using virt.io, and our bridge device is going to be our interface device, our network bridge, our in bridge here. So we can go ahead and grab that, put that in there, apply, and that's going to be our network connection for this virtual machine. So this is still loading. What is it doing? Oh, begin SSH husky fingerprints found for user server. I think it did it. I think it done. Did it finish? Ah, here we are. Pi-hole login, and our login was Pi-hole, and our password, if I can remember it, because I suck at remembering things. That was capital. Okay. Clear. Alrighty, cool. So now we have our server. It is our Pi-hole server. It's 5.5, 5.15 generic, 6.6 Ubuntu SMP Friday, blah 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 blah. Alright, that's all there. We're gonna go ahead and turn it off, and we can turn it back on. And when we turn it back on, we will have our network connection, because we now have all this set up here. I'm gonna make sure it's turned on in here. Oh, nope, I gotta turn on our NIC. And we turn it on. Cool. Alrighty. Now everything is loading. Okay, and here we are back at the login again. We have our Pi-hole login and our password. ifconfig. We check. Oh, right. NetTool is not installed. IPA. We do have network. Yes, right here. We have an internet address of 192.168.1.117. So we should be able to sudo apt update. And we are able to update everything. Nice. Awesome. And just to make it easier for me, because I like NetTools apt install NetTools. Alright, let's clear that on out. ifconfig. Yep, we have our thing, and we're connected to the internet now. So now we can go ahead and go to the GitHub of Pi-hole, and they have a whole walk down on here on how to install it. We're going to do it through curl. It'll be the easiest. So I'm going to put you here and put that there, and you can come over here, because we're going to type this in. Should see if we have curl installed though. No, we didn't have curl installed. Okay. Alright. Now we're going to curl SSL https://install.pi-hole .net, pipe it into bash, and that should go ahead and start the install. There we go. Alrighty. Now, it does say here, piping to bash is a controversial thing as it prevents you from reading code that is about to run on your system. Therefore, we provide these alternative installation methods which allow you to code review before installation. It's probably best to code review things, but considering it's warning you about it, I doubt there's really anything to be a real issue with just doing it with this, but it's just good practice, I guess. This installer will transfer your device into a network-wide ad blocker. Yes. Pi-hole is free but powered by your donations. Yes. The Pi-hole is a server that needs a static IP address to function properly. Important if you have not already done so, you must ensure that this device has a static IP. So I might need to do that. Depending on your operating system, there may be ways to achieve this through DHCP reservation or assigning one. Please continue with the static addressing has been configured. Okay, so we're going to go ahead and do that real quick, actually. Sudo apt install nmtui. Okay, it's not nmtui. I gotta figure out what the package was real quick. Damn it. Alrighty, so we're going to go ahead and install Network Manager, and should allow us to edit our IP addresses. Okay, cool. There we go. So we're going to edit a connection, wherever it may be. Okay, it's a little squished, but we can work with it. I'm gonna add an Ethernet connection, and it's going to do it all automatically. For IPv4 though, we want to change our address, IPv4 configuration. Instead of automatic, I want to do manual. Our addresses for this will be 192.168.1. Let's just say 73. We'll do add. No, remove. Okay, addresses. Our gateway address is going to be 192.168.1.1, I believe, is my gateway. I can go ahead and check it real quick, actually. Just make sure, because I just switched to Spectrum, so they changed all my addresses. 8.1.1. Yeah, okay, it's 1.1. Okay, and with that, we have our everything set here. We're going to leave the IPv6 configuration to automatic, and everything okay here. Okay, Ethernet connection. Let me just check it one more time just to make sure. Device. Okay, yep, everything looks good. Okay, back. Okay, quit. Clear the screen. I have config. Let it do its thing. It'll take a second. Well, it doesn't seem to be changing. So, actually, I'm pretty sure I can do it in here. Word IO disk with a NIC. IP address. Yeah, because the IP address can change here based on the actual link, but I don't think I set it in here. I think it should be fine in here, actually. So, okay, I guess I don't have to change it since it's just going to stay the same anyway once it's bridged. But the INET address is just going to be the 192.168.1.117. Okay, so I'm back, and it turns out that the virtual machine, since it is going to be on a bridge network, I don't really have to worry about the IP address changing. It'll stay the same. It's not really going to go anywhere. And this is just for the project. But if you are building on actual bare metal hardware or anything, you might want to change your static IP address on your system, just to make sure it stays the same and doesn't change. That'll be fine. All right. Now we have our DNS providers. I'm a big fan of Cloudflare's DNS, so we're going to stay with Cloudflare. Pi-hole returns third-party lists. In order to block sites, you can use the suggested below and or your own after installation. Yes. Do you want to install the admin web interface? Yes. A web server is required for your admin web interface. Do you want to install light HTTPD to require PHP modules? So this is where we're going to go whenever we want to look at all their statistics and stuff for our DNS queries and all that. So we're going to say yes. Would you like to enable query logging? Yes, we can do that. Select privacy mode. We're going to just show everything. Okay. And it's going to go ahead and finish doing all this. Alrighty, here we are. Okay, so we have our whole setup here. I'm gonna go ahead and write this password down because after it finishes, you need this password to log into the admin interface. So I'm gonna go ahead and put this in my notes real quick, and then we can continue where we were. 3D Z PD CZT. And our IP address is all that. If you have not done already, the above IP should be set to stat. Yep, we know all that. The web interface is going to be on 192.168.1.117/admin or pi.hole/admin. So now the Pi-hole server is set up. We have it running. It's all here, and if we want to go ahead and check that out, since it is on the same network, I can do it from the host system. So the virtual machine is set for right now until we do some securing in a little bit. But here, I should be able to now go to the web interface 1.117.7/admin, and here we are. Here's the Pi-hole server. The password was the long string down there. What was it? Let's see, 3D Z P D C Z T. Alrighty, I'm gonna remember that so I don't have to keep doing it, but I'm gonna log in. And I got it wrong already. I'm gonna set a new password. I think it should just update. Yeah, there we go. Okay. And now we're in. And we see here we have, it comes already pre-installed with a bunch of domains on an ad list. So now we can see here that there are a bunch of ads. There's GitHub's content, Stephen Block host, masters hosts. We go to that. There's all these websites that send ads, and these are all blocked by the actual things. These advertisement, axitraders.com, api.axitraders, Carnosaur S spy cashnow.ee. It's just a bunch of web servers that track all your shit. So with that all set up now, we can go ahead and use this IP address actually on our router for a global DNS blocker for our entire network now. Okay, so I got it all configured and set up. It didn't want to work with my router globally. I do have a Spectrum router, so it's probably something to do with that. But you can still configure your DNS server manually, and that's what I did. I went ahead over here and I set it up, so it is manually now set. And I even set it up on my phone so we can get some more queries going on. It's already blocking queries too, so it's already blocked some of the telemetry that comes with my web browser. Over here too, you can see it's already collecting all this as well. The 55 is my phone, the 25 is my computer. So if I check out that, and I can see all the requests that it's making right now. So we know it's working now. So I'm actually also, while I'm here, I'm going to go ahead and set up an SSH keygen so that I can SSH to the Pi server. So we're going to go ahead and open up a terminal. I'm going to do a lot of, like 8 of them open. So many of them open. But we're going to do this SSH keygen, the RSA-B4096, and this is going to make it so we don't have to use a password anymore for our SSH server. File in which to save the key society is like, alrighty, cool. That'll go there. Enter the passphrase, empty for no passphrase. We can set up if we want like a passphrase for it. I recommend setting one. I'm just gonna set it as my password. And confirm it. And we have generated our key here. So in order to put that on the actual server itself, we can do copy SSH ID. Oh, it's SSH copy ID. I see now. I got it wrong. I had to Google it real quick. But back here, we do SSH copy ID. And with that, we can specify our file is under home, in our home directory. Are we already there? Our home, let's just say, or say public key. Whoop. Source of keys to be installed. And I'm going to do, and we're going to do it at pi-hole at 92.168.1.117. Let's specify. Cool. Okay. There we go. We got that. There. Yes. The password for our Pi-hole server. Cool. Now we can log into the machine with just SSH Pi-hole at 192.168.1.117. Enter passphrase for the key that I set up. And boom, we are in. We now have SSH key authorization now. We can do it without a password. So now that I'm in the server, I'm going to go ahead and sudo nano etc ssh and our sshd config. And here. And here. I can go ahead and I'm going to change the port so we're not listening on port 22 anymore. We're going to just change it, make it a little more confusing for anybody else that might be trying to get to our server. We're going to pub key authentication is yes. We want to change, where was it? PAM, use PAM. We're going to change that to no since we're not using passwords anymore. It should be up here then. Password authentication. We're going to go ahead and disable password authentication so that now you can no longer use a password to connect to the server. You have to have a private key. And thus, that would eliminate any types of brute force attacking on the actual server itself. And in this server, we have it set up so that we can no longer get brute forced. Cool. Okay. Allow and set up now UFW for firewall. So, okay, so I went ahead and figured out how to do this, right? So we're going to sudo UFW allow from 92.168.1.25, and that's going to be our host system, and that's updated. And then we're going to do sudo UFW reject. We're going to do reject from 192.1.0/24 for the whole range, so nothing else can get in to our Pi-hole server. It'll just be that. Sudo UFW show numbered UFW enable numbered. So we have our rule set up. So 1911 is allowed in anywhere, and anywhere is allowed in from our IP address, and then we're going to reject all other IP addresses within our network. So only one of them should be allowed. Okay, so I ran into a slight problem where after doing that rule, I realized that is stopping my phone as well from connecting to the Wi-Fi, so I couldn't SSH if it didn't have access. So I went ahead and set it here so that it does have access now, and I should be able to attempt to SSH into it. And from there, I can go ahead and go to my terminal on my phone. I can install OpenSSH. It's going to do its little updates. And okay. Okay, so I ran into a slight problem here where I was not able to get connection on my phone because it was in the block list of the entire IP range. So Do keep that in mind too if you are going to secure this, that you can't use your entire network range, or else you're not going to be able to have any of your devices connect to your Pi-hole server. But I went ahead and I added my phone to the block list, or to the allow list, and my main computer to the allow list, and then the rest of the network is not allowed to get on my Pi-hole. So right now it's only set up, not network-wide, just right now it's only blocking DNS queries, and it's all that for my computer and for my phone. But for my phone, since I do have the SSH server set to keys only, I should not be able to SSH into it with a password. So I'm going to go ahead and try that. So if I do the Pi-hole server at the IP address and attempt to connect, it says it looks like this is the first time you tried connecting. Do you want to accept? I accept it. Please enter the password for the Pi-hole server. And if I do that, I'm able to SSH because I completely forgot to restart it afterwards. Oh boy. Okay, so if we might have to do this first. Authenticating as. Okay. So now that's restarted. Pi-hole should have restarted. SSHD and SSH servers. Okay, now that I have it all restarted, I went ahead and I attempted to connect again, and now I'm getting connection refused. So that means that I can now no longer use the password to connect to the SSH server. And with that, I think we have everything secured here on this system. It can't be brute forced. It can't have anybody log into it from any other IP address. It is also encrypted by default. Whenever we were setting it up, the LVM means that it is encrypted there on the virtual volume that's on there. We restrict access to elevated or administrative privilege to specific users, so only one user is on the server. It's the Pi-hole user, and that's the only one that has access to anything elevated or administrative. We don't have a root account, so that's not a thing. The complexity or restriction of the use on the passwords, we didn't do anything about this, but we do have the interdices by write access to sensitive system files, so we can also go ahead and can restrict write access. Restrict write access. Well, for SSH, that already comes restricted, really, because the only person that can write to the file, it would be your administrator user, so that's already done too. And I think this server is secured, so it actually is working right now. Everything is set up here. It's still getting queries. It's all good. We did the SSH key pair, so it can't be logged into from just the password. We set up the IP blocking, so only my phone and the computer can SSH to it. And it also can't get any request from any other IP addresses. And that is everything that I think I could do right now to really secure this, to make it not get touched or hacked by another malicious party. This has been the Pi-hole server. I hope this was at all useful and I taught you something new or showed you how to set this all up. Thank you for your time.